In this lesson, 4.1, we're going to be talking about vectors and translations. But before we jump into that, I just want to quick point out, in Chapter 4, the title of Chapter 4 is about transformations. So transformations, you'll see here, is our first vocabulary word, okay? So transformations is just kind of the general topic of the chapter. And then what they're going to do is in each lesson, they're going to go through a type of a transformation. Now you'll notice here that there's 6 lessons. As of right now, we're only going to cover 4 of the 6, and if we have time at the end, we'll probably circle back and talk about these 2. But these 2 lessons right here, really, we don't need them. It's kind of, maybe nice to know, but it's not really helpful in the field of mathematics. And so just for time's sake, we're going to skip those. All right, so I actually want to come down here to the first vocabulary word where it says a transformation, okay? Your book likes to use the word function, so they kind of talk about this as a function, but I kind of think of it as an operation. So basically, like, what are you doing? So it's an operation that moves a figure, maybe to a new location if you want to say, but it really just moves a figure, okay? Now, most transformations do not change the size or shape. So in today, we're going to be doing a translation. So in a translation, all we're going to do is really take this. Now, I know this is not necessarily a triangle, but let's just envision it is. Or you can take this bullseye here. We're going to take this figure and we're just going to move it somewhere else, okay? And then the next day, we'll do a different type of transformation. So again, they go through basically 4 different types of transformations. Let's hit a couple more here. So pre-image. The pre-image is the original figure. Or if you kind of want to say the starting. So whenever they talk about the pre-image, this is the figure that we started with. And let's just say we were talking about a triangle, they would just call it like triangle ABC, okay? So this is the original, and then the image is what we would call like the end figure. So this is like where you stop. Now, a lot of times what you'll see is they'll take the original letters, whatever it is, and then they'll put these things called prime. So it'll be A prime, B prime, C prime. Now they kind of look a lot like apostrophes, but in math class we call them primes, okay? So this is our first transformation. So if you notice, the words are really similar. So you want to think of transformation is like this big overlying like idea, okay, or concept. So this would be like, say, Hudsonville Public Schools. And then you would say, well, what school do you go to? Well, I go to the freshman campus, or I go to the high school, or I go to Baldwin. So this would be like number 1 underneath transformation. So a translation, I sort of think of it as just a slide. That's like the easiest definition. But basically what you're going to do is you're going to move every point in a direction. So you might already know, you have the note packet in front of you, but if you look at the next lesson, you'll see there's reflections, and then if you look again, you'll see there's rotations. So you can kind of see where this chapter is going, okay? So this just happens to be the first one. Now, in a translation, they want you to have this idea about what is a rigid motion. Now, this is never a word that you're going to hear them necessarily say, but the concept over here is probably more important, okay? So a rigid motion basically means that you're going to preserve the length of whatever it is. So if it's a triangle, it means the side lengths don't change. So like, let's say you had a triangle that looked like this, and this was like 3 centimeters. When you move this somewhere else, that means that this side length right here, or all the sides, but let's say this side length, this doesn't change how long it is. So it stays 3 centimeters. So you're going to preserve the length and the angle measures. So what they're basically saying is if this is like a right angle, when you move it, it's going to stay a right angle, okay? Now, a composition of transformations. Whenever you see this word composition, basically this just means two or more. So you can have a composition of rotations. You can have a composition really of anything, but it just means two or more, let's just say like movements together. Now in our class, they're not going to get too tricky. So they're either going to maybe do like a translation, and then they do this like little circle thing. So it's like a little, it's almost like a degree symbol, but it's kind of in the middle with like a reflection. Or they might do a translation with a rotation. They're not going to get too complicated in our chapter, but if you were to go on to higher level math, you might see multiple, like you might add on, like over here now, you might add on a rotation, but in our class, we typically stay with about two, okay? So let's circle back up here, okay? One of the things that they use with translations is they use vectors. So vectors are just kind of how far you moved something. Vectors typically don't stand alone, but they're going to give you some alone questions. So if you look down at 1 through 3, these are alone vector questions, but typically vectors are used with another shape. So I'm going to use a pencil here. Maybe you would have like a triangle sitting right here, and they would tell you to move this triangle however long this vector is. So many times vectors are not alone, but they're just trying to get you to understand the concept of a vector, okay? So first of all, vectors look like rays. It might be hard to see on my projection here, especially just because, you know, it doesn't always project that great. But if you look really closely at the symbol above the Q, I'm going to rewrite it here. Okay, so the symbol above looks like that. It only has half of the arrowhead. That's how you can tell the difference between a vector and a ray. So a ray would have a full arrowhead, a vector only has half. And basically what this is telling you, rays go on forever. So rays would start at P and then technically go on. There's no end to it. A vector is a starting and a stopping. So they call this the initial point, and you can kind of see it right over here. So they call this the initial point is where it starts, and they call this the terminal point. This is where it ends. You don't have to worry too much about that. Really what you need to worry more about is this thing called the component form. The component form is basically how big is this. So notice it's 5 units from here to the right. So it's 5 units to the right, and it's 3 units tall. So they'll often use these kind of almost greater than, less than looking brackets to signify a vector. If you use curved brackets, this is a location. So that would be like over 5 up 3. This is a location. But when you see these, again, I kind of call them greater than, less than symbols. This is telling you that that's how long it is. So it's over 5 up 3. That's how long the vector is. And I don't have a ruler here, but if you had a ruler, like you could get it out and you could like physically measure it. So vectors are very specific lengths, okay? And so down at the bottom, they just want you to do 2 things. They want you to name the vector, and they want you to write the component form, okay? So I'll do the first one, and then you can pause the video if you want to and try the other 2. So notice M does not have the arrow. So M is our start, and it goes through N. Now again, very similar to a ray. The only thing different is because this is a vector, we only do half of the arrowhead. And I don't really think it makes a big difference, but you always see the top half. You never see the bottom half. So you don't see this, no matter which way it's going. So even, do you know how it's number 2? You see how it's going towards the left? You always do the symbol the same. That's the only one in the computer. So I don't have a good explanation for that. That's just what you do. Okay, so now, what is my horizontal? So from here to here. So I count 1, 2, 3, 4. So I'm going over 4. And then how far up? So from here to here. So 1, 2, 3, 4, 5, 6. So I went up 6. And that would be my component form. Okay, so if you want to pause the video here, you can try numbers 2 and 3. All right, hopefully you paused it. If not, quick do that if you want to. So that's how I name it. And then the same thing here, K to J, that's how I would name it. Remember, you only do the top half, and this is what they call the initial, and then the arrowhead is what they call the terminal. All right, and then I just need to count. So from here, I go 1, 2, 3, 4, 5. So left 5, and then looks like down 1. And then I do the same thing here. How many? 1, 2, 3, 4, 5. Up 1, 2, 3. So left 5, up 3. And we still use the positives and negatives just like you normally would if you were graphing something. We just, again, change the brackets. Okay, so now they're really going to put it together. And this is typically more of what you would see, okay? So they want you to graph the triangle that you have here. So you're going to graph these. And then you're going to translate it using this vector, okay? So let's quick plot this. All right, so here's my triangle. Now what I'm going to do, I thought I had a red pen. Sorry, I'll have to use a pencil. What I'm going to basically do is I'm going to count 4 to the right. So it doesn't matter which point I start with. I'll just start with B. 1, 2, 3, 4 to the right. And then I'm going to go down 3. 1, 2, 3. And here's my new B location. And I'm going to do the same thing for C. I'm going to count 4, 1, 2, 3, 4. Down 1, 2, 3. And remember, what they're telling you is that this distance is preserved. So do you see that this distance is 1, 2, 3, 1, 2, 3. So however long this segment is, it's going to be the same length here. So now we do the same thing with A. 1, 2, 3, 4. 1, 2, 3. And here's my new one. And sometimes what I'll do is sometimes I'll shade in my new one like that, just so you guys can tell the difference. You should be able to tell the difference because of the primes, because I have those labeled, but sometimes it's just hard on the projection. So sometimes I'll kind of shade that one in so you can see it, okay? Now this one is the same, but you can notice that the vector looks a little different. Sometimes they write it like this. It's not a big deal. This is called component form. This is called vector form. It really doesn't make a big difference to me. I think more people are comfortable like this just because it's kind of quicker. But do you notice how, again, it's kind of like the greater than, less than brackets? Notice these are the curved. So do you see how they put x minus 5? Because you couldn't just put minus 5 or it's a location. So you just have to kind of know how to read both of them. But notice the original triangle is the same. So I'm going to graph still the original triangle. So the original triangle didn't change. Now they want me to basically go left 5, up 3. So if you wanted, you could rewrite it like this. That would be the exact same thing. It's just a different way to be able to view it. So left 5, and up 3. 1, 2, 3. So here's my new A. And it doesn't matter what point you start with. And you can kind of see how it would be a pain if you had a larger figure. Like if you had like an octagon or something like that, it would be quite a bit, you know, it would be just longer. So then left 5 and then up 3. 1, 2, 3. So again, that's why a lot of times I call a translation, I'll call it a slide. Because you're just taking this triangle and you're just kind of moving it. Now, if you are asked to find the vector, which is what they're asking you to do down here, okay? If you're asked to find the vector, notice if I were to go back to the original here, if I were to connect any point, it doesn't matter what point you pick, A, B, or C, just pick one. If you were to connect the original to the new, so what we call the pre-image to the image, this is the vector right there. Okay, Now, the vector, if I do A to A or if I would have done C to C, is the same vector. It's just in a different location. But if I were to put my triangle, like if I were to take a piece of paper, which I'm at home here, so I don't have tracing paper, but if I were to take a piece of paper and if I were to put it over top and then I were to slide this triangle down, basically I'm sliding it along the vector. So it just matches up. So if I go down to number 6, I can pick any one from the original. Now remember, the original is the one that does not have the prime. So in this case, the original is the solid and the image is the dashed. So if I start at the original and I go towards the image, that's the vector right there, okay? They want me just to come up with a rule, which is basically what is the vector. So we just have to count how many did it move over and how many did it move up. So 1, 2, 3, 4. So it moved right 4, and then it moved up 1, 2, 3. So that is my vector. Now, if you want to go to this form, which we call a vector form, you would just say x plus 4 and y plus 3. So do you see how they're very similar? One, they just have different brackets and things like that. So you can write it whichever way you want. It doesn't really bother me. All right, so why don't you go ahead and try 7 real quick without me. All right, hopefully you tried it. I'm just going Q to Q just because it's easiest. You can go whatever one you want. So it looks like I went right 1, and I go down 1, 2, 3. And I'm done, okay? So again, you have all the information you need. All they're going to do now is kind of just twist and turn the questions on you. So if we take a look at number 8, they're giving us this point. So this is just one point on a graph. So if you want to envision it, you know, it's over 4, up 5. Here's your point J. What they're telling you is just where is the new point. So where is the image? Where is the new point J? So if it's a point, we're going to use the regular brackets if we do this to it. So all we have to do is plug 4 in here. So if we plug 4 in, 4 plus 6 would be 10. And if we plug 5 in, 5 minus 3 would be 2. So if you were to take this point and apply this vector, this is your new location. So try the same concept here with R. So notice they're just giving you a new coordinate. All right, so hopefully you quickly just plug those in. So 0 plus 6 and 5 minus 3, and we're done, okay? All right, now let's take this concept and let's go backwards. So this now is this piece, okay? So now they're going backwards. So kind of envision it like this. Here's the original, and here's the answer. Now, you're still doing this vector. So you're still doing x plus 6 and y minus 3. So basically what they're asking you is what number had to be right here that when you add 6, you get 0. So hopefully you're thinking -6. But if you're not good with that, what you could do is you could do x plus 6 is equal to 0, and then you could solve it. So if you look at this, what number do I have to put right here that when I subtract 3, I get 0 back? So the answer should be +3. But again, if you want, you can do y minus 3 is equal to 0, and then you could solve it. So go ahead and try number 11. Sorry, I wrote down that one up there. Okay, so same rule. This one might be maybe a little bit harder. What number needs to go here that when I add 6, I get -2? So if you're not good at guessing, just make yourself a little equation. X plus 6 is equal to -2. So when you solve this, you'll notice it's -8. And then do the same thing over here. What number needs to go here that when I subtract 3, I get +5? So if you're not good, just do y minus 3 is equal to 5, and then when you solve this, you'll see it's 8. So again, you know all the concepts. It's just how they're going to kind of twist and turn the questions on you. All right. So if this is our last page here, and in this one here, now they're doing what they call a composite. But because it's only day one, you only have one transformation, so you really don't have two separate items. So notice we're just doing two translations. But again, if you look ahead in your note packet, you'll see like on tomorrow's lesson, notice you'll see a translation with a reflection. So sometimes they'll do two different ones. And then when we get to rotations, you'll see over here, they'll do like a reflection with a rotation, or maybe they'll do a translation with a rotation. So remember, a composite is simply two or more. But in your class, they're only going to do two, but it could be more, all right? So let's graph the original. And we don't really care what kind of a triangle this is. We just need to know where it's located at. Now, there's two things you can do. You can either take these and physically count them on the graph. So I'm just going to show you one point. I'm going to show you point C, just simply because it's closest to the edge here. So what I could do is I could go right one, down three. 1, 2, 3. Here's the first location of C. And then I could do the same thing for B and for A. Then I take this location and I do this to it. So I would go left 2, 1, 2, and then I would go down 5. 1, 2, 3, 4, 5. And this would be my final location. So notice how I used a double prime. So you can either, one, you can count it on the graph. That's your first option if you would like to do that. 2, you could combine the movements. So that's what I sometimes like to do. So what I do is I put these together. So if you're going to make me go right 1 and then left 2, when I put these together, I'm technically only going left 1 because I'm kind of like going and then backtracking. I do the same thing here. If you're going to ask me to go essentially down 3, wherever I'm at, let's say I'm here, you want me to go down 3, and then you want me to go down 5 more. Essentially, if I put these together, I'm really going down 8. So what I do is I put them together, and then I simply just add these out, or like add them together. So I take A. Now notice I'm putting curved brackets because it's a final location. So I take A, and I'm going to go -1 plus -1. So the final location of A is technically going to be, or here, let's do C. So if I take C and I go 2 plus a -1, right? 2 plus a -1. That's going to be my final location. So 1, see where it's my final location on the X scale. Now let me do the Y scale. 3 plus -8. Notice where it is. So I like to do what I kind of call combining my movements first. If you'd rather count them on the graph, you can do that too. So I'll finish off letter A. So letter A, I already did -1 and plus -1. And now I'm going to go 3 plus -8. So -2, -5 is my final location for A. So I kind of skipped over the first step. And now I do B. So 2 and -1, 6 and -8, and then I draw it. And again, a lot of times I'll kind of shade it in for you. You don't have to shade it in, but a lot of times I'll shade it in simply so that you can kind of see where the last location is. And then that would be the final answer right there. So this is just kind of my work to get there, all right? So 13, again, is now kind of switching up the concept a little. So why don't you go ahead and graph it, and why don't you try this one on your own without me? All right, hopefully you paused it. So the question is asking you, what are the coordinates of B and C? So this is my final answer right here. But I pretty much need to figure out how far is this thing moving? Because I mean, I could make up any location I wanted. Notice it tells you that the image of A, so the image of A is going to land right here. That's the image of A. So let's figure out how far A moved to the image. So if I count, that would be 4 to the left, and that would be down 4. So that's how far A moved. Well, based on one of our definitions at the beginning, what we call rigid, it means that all of the lengths are preserved and the angles. So whatever angle this is right here, whether it's 90 or it's not 90, I'm not going to calculate slope right now, but whatever this angle is, it has to stay the same. So however far A moved, then B and C have to move the same. So all we have to do now is take 2 plus negative 4, 2 plus negative 4, and that's our B location. And then we do the same thing with C. 6 plus negative 4, 2 plus negative 4, and that's our C location. So again, don't overthink these. They should be fairly easy, but sometimes it's hard just to know what they're asking for, okay? All right, number 14, last one here. It says, a translation maps the blue figure to the red. So I wrote them on here because if you look in your book, they are actually blue and red. But honestly, the colors, it doesn't make one bit of difference. It says, find the value of each variable. So you're going to notice there's 3 variables. There's an A, a B, and a C. It makes no difference which one you do first, okay? How about I'll just tackle A because it is alphabetical. So if this was a translation, it cannot twist or turn. It simply has to slide. And again, it doesn't matter if blue was first or second. But basically, this triangle matches this triangle. It just slides. Or this triangle slides. Translations cannot turn. So we know that this angle right here matches this angle. So if we look, I don't know this one, but I can see this is 55. So triangles preserve angle measurement. Again, that's what's called a rigid motion. So angle measures are preserved. So if this is 55, then that means this is 55. And by triangle sum theorem, we know that the entire triangle has to total 180. So if we take 180 minus off 90 minus off 55, that means this top angle must be 35. So we're just using some of our previous chapter knowledge. All right, now let's tackle B. Notice B is a side length. So B is this vertical side right here. So it's this vertical piece, which has to match this vertical piece. Well, if this side is 20, then that makes this side also 20. So if we just simply solve this equation, then we know B must be 14. Now notice I didn't put a degree symbol. I can't put units because I don't know what the units are. Maybe it's inches or centimeters, but it's not a degree because it's a side. And then the same thing goes for C. If you look where C is, so C is down on the bottom here, that's this side, which goes over here to this side. So that means this is also 14. Now that one might be a little bit harder to solve in your head. You know, move the 6. And you've got 20, and now divide, and so you can see it's 5. So these are the 3 values that they're looking for. And once again, you should notice how much algebra they kind of mix in without saying we're doing algebra. We don't get in any big equations, but we're going to see lots of these, what I would call little 1 and 2 steppers. But that concludes the first lesson.